Have you ever wondered how a surfboard works? Well, we have, and as it turns out, the board's design is an essential part of the sport, and some changes to their designs can affect the board's performance. So today we're going to explain you why.
When it comes to grip, there's one water property that allows the board to stick to the water, and that is adhesion, which involves molecules of one kind attracting others from another kind. So our boards are able to grip the wave because some of the water hits its bottom and flows around the inside of the rail, sticking to it.
The speed partially comes from gravity, but there are other elements involved. The majority of the water hits the bottom of the board and goes along it until exciting through the tail. Newton's third law of motion states that for every action there is an equal and opposite reaction. So when the water hits the bottom, the board acts a hydrodynamic force that generates lift and forward thrust.
Volume is really important since it tells us how buoyant our surfboard will be. In other words, how well will it float. Buoyancy has to do with the differences in pressures between the bottom of a submerged object and the top. The upward force from the water has to be greater than the downward force.
Buoyancy is essential because the more we float, the less drag or resistance to motion our bodies will generate and the faster we can paddle. We also need to take into account the surfer's weight. A heavier surfer will need more buoyancy to float, so he'll need a board with more volume.
The fins of a board provide stability, preventing the board from sliding and allowing the surfer to rotate it. And some fins also may generate lift. The fins are curved on one side and flat on the other, which produces lift toward the wave face. Bernoulli's principle states that the more pressure, the less speed, and vice versa.
So, since one side of the fin is curved, the water on that side has to travel more distance to reach the same point as the water on the flat side. Consequently, the curved side will have more speed and less pressure.
The water on the flat side flows more slowly, which means that it has a higher pressure, and this pressure pushes the fin and board further into the wave face. However, the water from the curved side is traveling away from the wave face. In return, Newton's third law of motion explains that the surfboard is directed towards the wave face.
The nose of the board has a great influence when a surfer paddles since it's the part that has the first contact with water. Water molecules are strongly attracted to each other. This is called cohesion, which results in water having resistance to rupturing when we put it under pressure. Hence, a surfboard has to be able to rupture the water and slide through it with as less drag as possible, and having a sharp point breaks the water faster but doesn't provide the same lift as a curved nose.
On the other hand, the board's back half acts as a wing and generates lift. The more area it has, the more lift it will generate. Thus, a surfer has more speed and less drag. However, lift is not always something good, since at high speeds it's harder to control the board. That's why surfers use narrower boards on bigger waves to get more control. The outline curve is also important since it defines a surfer's ability to disengage the rail faster and be able to change direction.
Now you know that surfboard designs are a vital part of the sport. Having a good board is an advantage, but the surfer's experience and ability makes a difference in an important competition such as the Olympic Games.